In this lecture I am going to solve the same problem which I solved in the previous lecture by using an alternate method. Okay, so instead of taking formula and you know like a lengthy method, I'm going to use a shortcut method. Let's say this is my 0. The 0 occurs with the probability 1/8, and 1 it occurs with the probability 1/4. Then 2 occurs with the probability 1/2, and 3 occurs with the probability 1/8. The right hand side also I may have 0. This is 0. Let me use some other color. 0, 1, then 2, then this is 3, and this is 0, 1, 2, 3. Okay, now what is the function here? I am defining y equal to 2x, right? So capital X. So therefore g of x equal to 2x, right? So the function is g of x equal to 2x here. When x equal to 0, 2 times 0 it goes here. So this is the mapping, corresponding mapping. So the same probability occurs 1/8. Now when x equal to 1, then 2 times 1, 2. So therefore it goes there. So the probability is 1/4. When x equal to 2, then it goes to 4. So it is 1/2 probability. This is 4. When x equal to 3, then it goes to 6. Let me change the color. This is 5. This is 6. Okay, so this goes like this. So this probability is 1/8. So in between the probability is 0, here is 0, and here is 0. Straight away you can write down. So what is the probability mass function? The probability mass function is at 0 you have 1/8, and at 1 you have 1/4. At 2 the probability is 0, right? One minute, sorry, this is 1. I'm sorry. So at 1 the probability is 0, at 2 the probability is 1/2, and 3 it is 0, and 4 it is 1/2, and at 5 it is 0, at 6 it is 1/8. Straight away you can find out. Okay, and what is the next one? Next one is g of x equal to x square. So y is equal to x square. So same way you can work this problem also. Like this is 0, 1, 2, 3. Let me change the color. The 0, 1, 2, 3. 0 occurs with the probability 1/8, 1/4. This is 1/2. This is 1/8. Now in the y-axis, this is 0. What is the function now? Y equal to x square. So 0 square, you square it to 0 square, which is equal to 0. 0, the probability 1/8. Now 1 square, you square it, again you will reach this position 1 with the probability 1/2. And 2 square, if you square it, you will go to 4th position, probability 1/2. Let me change the color. This is 4, this is 0, 1, 2, and 3. 2 and 3 no value, and 4 you have a value, and again 5 no value, 6 no value, 7 no value, 8 no value, only 9 you have a value. So this 3 square becomes 9. So you'll get 9 value. So this is a probability mass function. So here the probability is 0, here the probability is 0, here 0, here 0, and this value is 0, and this value is 0, right? So you can draw the probability mass function for y in this case. So 1/8, 1/4 when x equal to 0, and 1, for 2 0, for 3 0, for 4 it is 1/2, then for 5 0, for 6 0, for 7 0, for 8 0, for 9 it is again 1/8. If you add all the properties, 1/8 plus 1/4 plus 1 half plus 1/8 total equal to 1. So it is a legitimate probability mass function. So the derived distribution is also a legitimate probability mass function. Even if you take here also, you can add all these probabilities, it will sum them up to 1. So 1/8 plus 1/4 plus 1 half plus 1/8, so total equal to 1. So the original random variable also satisfies the probability, total probability theorem, and the derived distribution also satisfies. So this is a short way of doing the problem, then doing mathematically right summation and substitute the values and finding out. So this is one simple way. Similarly, you can cook up many problems for a discrete case, and the discrete case is pretty easier than the continuous case. So probably in the next class I will talk about some example problems for continuous random variable. Thank you very much.